Hi students, welcome. So here in this lecture we are going to talk about the conservative and non-conservative forces. So in detail we will discuss what are the conservative forces, how do we define these conservative forces, how do we find out whether there is a conservative or non-conservative force, right? And okay, so here when I am categorizing this category of the forces, when I am categorizing in the two categories, I am categorizing on the basis of the work done by the forces. This is on the basis of work done. So earlier we have done the category, but that was based on the other property, like we have done the contact type and non-contact type, and then on the basis of the fundamental nature we have done two kinds of the forces. But here we are saying on the basis of the work done. Okay. Now, like if we look in the real life, there are some forces which do the work, but they do not dissipate the energy. They will store the energy. Okay, what is the meaning of that? It's like, for example, gravitation. Okay, so look, let's suppose this is the object, right? And I'm taking the ground somewhere here. And this object is basically placed on the ground, right? And I'm lifting this object. So when I lift this object up, then I need to do some work, right? I'm just basically lifting this object with the zero velocity. I'm not giving any energy in the kinetic energy from it, right? I'm just working on the object just to move this object. So when this object is moving at that level, at this point, kinetic energy of this object is zero, right? If I just leave this object from this place, when this object goes back to this point, then it will have some kinetic energy when it reaches at this point. Now think about this, that from where this kinetic energy is coming. You are going to say that because of gravity there is a gravitational acceleration, right, in the downward direction. Because of that this object is getting the kinetic energy. Yes, that is correct. It means this here, the gravitation is storing the energy. When I am lifting up, I am doing the work. That work is not wasted. That work is stored in this block in the form of kinetic energy. Alright. Whereas if I take another example, let's suppose this is the object. It was here. I am displacing it horizontally. Right. Let's suppose this is a rough surface. The surface is having some friction. So this is a rough surface. Right. When I displace this object at this point, I need to do some work because there is the friction. I need to apply some force and continuously pull it against the friction. In this, I need to do some work, right? But when I release this object is not going to come back to original position. I need to apply some force and I need to bring this object back. So that is the difference. Friction here will do the negative work when I am pulling this object from this location to this location, like this. It is doing the against work, right? And when I am bringing this back object, then also it is doing the against work. It is doing the negative work. It is taking the energy from the system, right? So here this friction is not storing the energy. It is dissipating the energy in the another format, which is basically the heat energy, right? But it is not storing the energy in the other format. Okay. So that is the difference between these force, the gravitation force and the friction force. So if you look at all the forces, they can have these two kind of properties. Either they can be similar like the gravitation or they can be similar like the friction. Now just think about some examples which you can think that are similar to the gravitation and which are similar to the friction. Okay, so I will give you idea. Tell me, what about the spring force? Okay, just think it. Of course, once we completely define, then you will be able to understand. What about the air drag? Tell me, what about the electrostatic force? And what about the viscous force? Okay, these are the forces which are generally present in the nature and we will study in our 11th and the 12th class. So now look at this spring force and the electrostatic force or the gravitation force for that matter. These are having a similar properties of storing the energy, whereas these forces are dissipating the energy. Okay, so here I am giving this categorization on the basis of work done. These are the conservative forces. I am linking that. So these are the conservative forces and these are the non-conservative forces. Now let's go to the very fundamental definition of the conservative forces and the non-conservative forces. So conservative forces are those forces for them the work done is independent of path. So here I am defining the fundamental definition that these forces are those forces for them work done is independent of path. Let's have a look at this point. So here I am taking the example of again the gravitation. Let's suppose that the object and that object is placed somewhere at a height from the ground. Now I am changing the location of this object from this place to the another place. Let's suppose here. Let's suppose this particle is moving first in this path, then in this path, and then in a zigzag fashion like this, and then it is going to the same location. Okay, so here I am taking three different paths, path 1, path 2, path 3. All the paths are starting from same location and they are ending on the same location, but the difference is that the path is different in all three paths. So then can I say that the work done in the first path, basically it is the gravitation, we will say work done by the gravitation is mg multiplied by height difference, and when we are taking the object in the downward direction, then height is positive. We'll take the height h difference as positive, right? So can I say mgh? This is the work done by the gravitation when I am bringing the particle from the location A to location B. Same way in the path second as well, I can say that the work done is same mgh, and even in the path 3 this is same. Okay, so it means the gravitation is following this property where the work done in all three paths are same. So this is one of the property of the conservative forces. Then there is one more thing to this, is that the work done by the conservative forces in a closed path will be 0. Okay, so again to understand this statement, I am taking the example of the gravitation. Let's suppose that there is the particle which is placed on the ground. Okay, this particle is somewhere on the ground. Now I am taking this particle from this location A, which is on the ground, to a location B somewhere here, right? Any random location in this space. And now I am going something like this, and then I am coming back to the location A. So this is our first path A to B, and the second path is path B to A. The work done in the path A to B, because we are going up, the work done by the gravitation will be negative, right? Because the displacement is in upward direction and the force is acting in the downward direction. Then you will say that the work done is mg multiplied by minus h. So basically minus mgh. We know that the work done by the gravitation is independent of the path, right? It's just dependent on the initial and final location, where h is the height difference between the initial and final location. Basically, if I draw in this diagram, this is the h, right? Okay, now tell me what you think, what is the work done in the path B to A? Look, the gravitation is downward, right? And the displacement is also downward. So then tell me that the work done, will it be positive or not? Yes. And the work done is mg multiplied by h. And here h we will take it positive because we are moving down, and the work done by the gravitation is going to be positive. So then you will say work done by the gravitation is mg multiplied by h. Okay, now tell me what is the work done in the closed path. If I ask you what is the work done in the closed path A to B to A, then you will say basically this work done is work done A to B plus work done B to A. There is no doubt in that, right? So that is going to be minus mgh plus mgh. Will that become 0 or not? So through this illustration, I can explain you that the work done for the conservative force in a closed path is 0. Now no matter which kind of conservative force we take, it may be a spring force. You can just try to think about this spring force example. So like there is a spring, right? Let's suppose it is in the natural length, and now you are pulling this spring with a F force. Then of course the work done by the spring is going to be negative, right, from this A point to B point. Why? Because the spring force is basically in this direction and the displacement is in this direction. Now just think about when we are coming from B point to A point, this work done from B to A, will it be positive or not? Yes. So work done A to B is negative and work done B to A is positive. In total, can it become 0 or not? Yes. And it will become 0, right? So spring force, thus we can understand that, okay, work done by the spring force is going to be 0 in the closed path. That's why that is a conservative force, right? So this is how we can understand this. Now this is how we can do for each kind of conservative force. You can again prove this for the electrostatic force. The work done in a closed path will be 0 or work done will be independent of the path. Okay, now is there any mathematical method to find out whether the given force is a conservative force or not? Okay, yes, there is. The mathematical method says that if we have a conservative force, okay, for a conservative force, the curl F will be 0. Curl of the F vector will be 0. Now, what is the meaning of curl F? First of all, it is denoted like this. This is the symbol like the gradient only. But here we have cross F. That is 0. Now, how do we write it down mathematically? Is like this. Let's suppose the force, conservative force is Fxik plus Fyjk plus Fzkk. Okay, when I say that the curl F is 0, this is the meaning. The matrix of this I cap. So here in the first row we have I cap, j cap, k cap. In the second row we have the dou by dou x, dou by dou y and dou by dou z, which are the partial differentiations. And then we have fx, fy, fz. So that matrix value will be 0. That is how we can prove if this force is a conservative or not. Alright, so now we know what are the conservative force. So basically for a conservative force, work done is independent of the path. Second thing is work done by the conservative force in a closed path is 0, and this is the third point, that for a conservative force curl F will be 0. Okay. Now what about the non-conservative force? For a non-conservative force, the conditions will be just opposite of the conservative forces. So here we said that the work done is independent of path, but for the conservative forces the work done will be dependent. Okay, so we can take the example of like friction. So like for example, you have a path like this and you are going on this path from this location A. There is a particle which is going from this location A to location B, right? Now if this path is something like this, then the work done will be something, and if we have a path like this, then work might be something else, right? Of course it would be something else. We can just do a practical and from there we can get an idea that for sure this work done will be different. So it means work done is dependent on the path. Okay, now next, the just opposite condition is that the work done in a closed path is non-zero. Okay, so you can just visualize one example. Like for example, there is horizontal like this. Okay, just try to think. And if you right now you have something in front of you, you can just do the experiment. Let's suppose you have table in front of you and there is, let's suppose, mouse kept in front of you. Okay, so then you just try to drag this mouse. So you are dragging from A point to B point like this. So then you are doing the work. And when you are coming back, while the coming back also you need to do the work. Basically work done in the against the friction you need to do from going A to B and coming B to A. So work done by the friction in the total path is basically negative, that is non-zero, right? The another condition is that the curl of this force, non-conservative force. So I hope you understood the conservative and the non-conservative forces. This is in detail what is conservative force and the non-conservative force. You can use these conservative and non-conservative forces to calculate the potential energy and to define the potential energy, and the potential energy is just defined for the conservative forces, not for the non-conservative forces, because that will become meaningless, because the non-conservative forces will not store any kind of energy, right? So next, if you have doubts on any other thing and the especially the potential energy, I am going to upload the video on the potential energy. Stay tuned, and you can also watch the other videos available on the channel. Thank you.